Okay, so the topic for today is very interesting topic, and that is reminders. Right? Okay. So basically, there is a theorem which states that if we have two positive integers, let's suppose we have a and b, and if we divide b with a, there exists a unique quotient and a remainder. I will repeat that. If we have two positive integers, let's suppose a and b, and if we divide b with a, there exists a unique quotient and remainder. For example, if we have 20 and divide 20 with 5, so this goes 4, which is 20, and the result is 0, then the remainder is 0, right? Likewise, this is quotient, this is divisor, this is dividend, and this is remainder. This is remainder, right? So we can also write this as 5 into 4 plus 0 is equal to 20. What this mean? This means that in terms of the, okay, in terms of this is divisor into quotient plus remainder is equal to dividend. Everyone is with me till now? What I am doing?
Yes.
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 So just remember that the form which we usually use for B, A, Q, and R, this will be A, Q plus R is equal to B, right? This is dividend. This is remainder. This is divisor. And this is quotient. Okay. Now there are certain properties which we should know. The
We
first
couldn't hear the previous part. Your voice was lagging.
I just revised what I told earlier, that the actual form, the way of making equation is just like divisor into quotient plus remainder is equal to dividend. That is what I told earlier, right? Should I proceed forward?
Yes.
Okay. So there are certain properties. First of all, again considering two positive integers a and b for time being. Okay. If we divide b with a and the result is 0, this means that b is a multiple of a. For example, we have 30 and we divide this by 5, this will become 6, or remainder is 0. This means 30 is a multiple of 5, right? This is very first basic property. The next one is, in case we are having dividend less than the divisor. For example, if we divide b with a and b is less than a, in that case, a will go 0 and the result will be, the remainder will be b itself. So remember, if dividend is less than divisor, in that case, our remainder will be dividend itself. From this, we can also assume that our quotient could be 0 as well, right? This could be 0 and this could be positive value as well. Both could be the scenarios, right? Shall I proceed forward?
Can you give
Can
an
you
example
explain
of...
with this example? With an example.
For example, if we have 3, I'm dividing this by 5. So what will be the remainder? The remainder will be 3 because this goes 0, this is 0, and the remainder is 3 itself. So whenever this value is less than this value, the result remainder is same as the what is inside, what is dividend, right?
Yes, yes.
Okay. The third property is that again, considering that case, we have B, A, Q, and R. First of all, the remainder must be less than the divisor. According to this scenario, this could be equal to or greater than 0 and must be equal to or less than A minus 1. What this mean? This mean the range of the remainder will be from 0 to divisor minus 1. For example, we have case like, let's suppose we are dividing y by 4. What are the possible reminders in this case? For example, if y is 1, y is 2, y is 3, and y is 4, what are the possible reminders in this case? If y is 1, the remainder will be 1. If y is 2, the remainder is 2. If y is 3, remainder is 3. But if y is 4, the remainder is 0. Right? So the remainder must be in range 0 to 1 less than divisor. Right?
Right. Yes.
Okay. So the next property is, this is very basic, that if we divide any number, let's suppose we have 12, and if we divide this by 10, the remainder will be the last value. This is 1, this is 10, and the remainder is 2, which is a large digit, the unit digit. And let's suppose if we have 123, and if we divide by 100, this is 120, the 100, the remainder will be last two values, last two digits, right? This is a very basic thing.
Yes, right.
The next one is, in case we are having a very large number, so we can use a property that the remainder of A plus remainder of B is equal to the remainder of A plus remainder of B. This is a very helpful property. For example, if we are dividing, let's suppose we are dividing 11 by 10, we can also write this as 10 plus 1 over 10, right? We can write this as
Yes,
n
right.
over 10 plus 1 over 10, right? So when we are
Right.
dividing 10 by 10, the remainder will be 0. And in this case, we have dividend 1 and divisor 10. This is just like 110. So what will the remainder is in this case?
1.
1. So in this case, we have 0 plus 1. Our remainder is 1, right? So we can divide a number. This is helpful when we are having a larger number. We can just divide that into pieces. These properties include for the addition, and we can do same for the multiplication as well. For example, we can do that remainder of A into remainder of B. For example, we have a number 135, and if we divide this by 8, so just for the case of example, if we just open this, this is like 9 into 15 divided by 8, right? We can also write this as 9 into 8 into 15 over 8, right? We can also write this as 8 plus 1 divided by 9 plus into 8 plus 7 divided by 8.
Divided by 8. The
That's
first one will be divided by 8.
8
Yes,
plus
yes.
1 divided by 8.
Yes, yes.
9 by 8, 8, yes.
Okay. So this will be 8 over 8 plus 1 over 8 into 8 over 8 plus 7 by 8, right? So in this case, what will be the remainder? 0. In this case, what will be the remainder? 0. So we are left with 1 by
1 and
8
7.
into 7 by 8. So this will be, remainder is 1 in this case and 7 is in this case. And divide by, just keep dividing until the dividend is less than the divisor, right? Let's suppose if after multiplication above 2, let's suppose this is 2, this become 14. So you will again divide, this will be 8 plus 6 over 8. So reminder that case will be 6, right? Just keep doing this until the dividend is less than the divisor, right? This is very helpful. We will discuss how this is used. Okay.
Can you repeat the last statement? I mean, until, how we finish.
I just told you that you will finish whenever the dividend is less than the divisor. In our case, this becomes 7 over 8. So this is less than 8. So our remainder is 0. But let's suppose after multiplication, this become 9. For example, become 9. So 9 over 7, we can write this as 7 plus 2 over 9. 7 plus 2 over 7, right? 7 over 7 plus 2 by 7. This remainder is 0. And 2 by 7 will have remainder 2. Got my point?
Yes, yes.
Yes.
So this is just a brief intro. Though this is a very big topic, it will take at least 2 whole classes. Okay, let's discuss some question and see how the question could be asked in exam. Okay, let's have a very simple question. The question is that a positive integer please mute yourself. Integer n leaves a remainder 4 after divided by 6 and a remainder of 3 after divided by 5. A positive integer n leaves a remainder 4 after divided by 6 and leave a remainder of 3 after divided by 5. The question is, if n is greater than 30, what is the remainder that n leaves after division by 30? So options are 3, 12, 18, 22, and 28. I will repeat the question that a positive integer n leaves a remainder 4 after divided by 6 and leaves a remainder 3 after divided by 5. If n is greater than 30, what is the remainder that n leaves after division by 30? So we have 5 options: 3, 12, 18, 22, and 28. Just try to solve this question now. Just take 1 minute and try to see what is actually asked in the question, then I will explain. There are several ways to deal with this question. Okay, so one answer is 12. Any other answer? Okay, 12 is not the answer. Okay, let me explain now. The question states that, yes,
12.
no, 12 is not the answer. Okay, let me explain.
28.
Yes, 28 is the answer. Okay, now let's see the question. The question states that a positive integer n leaves a remainder 4 after divided by 6 and a remainder of 3 after divided by 5. Right, so we have 2 scenarios. We have integer n. When this is divided by 6, the remainder is 4. And when same is divided by 5, the remainder is 3, right? First thing. And afterward saying that if n is greater than 30, what is the remainder that it leaves after division by 30? Okay, now let's see. N is divided by 6, the remainder is 4. And when n is divided by 5, the remainder is 3. So let's just assume any quotient. Let's suppose this is A and this is B. And when both are positive, not positive, let's see whether positive or not. Okay, if we try to form equation out of this, what will be the equation? Divisor into quotient plus remainder is equal to dividend, right? Likewise, divisor into quotient plus remainder is equal to dividend. Now I told you earlier that the quotient could be 0 and could be positive. So let's consider a cases and see in what case we are getting a same n in both sides. Everyone is with me till now? A could be 0, 1, 2, 3 up to so on. And likewise, B could be 0, 1, 2, and 3 up to so on. If
Yes.
A is 0, n will become 4. If A is 1, so this will be 6 plus 4 equal to 10. If A is 2, this will become 12 plus 4, 16. If A is 3, what will this become? This will become 22, right? So there's just addition of 6 in each. Likewise, if I see the other side, we have when B is 0, this will become 3. When B is 1, this will become 8. When B is 2, this will become 13. So this will move in order 18, 3, 8, 13, 18, then 23, 28 up to so on, right?
5.
So
Difference of 5.
Can you repeat the second line?
which part?
Part B.
I'm saying that I told you that quotient could be actually non-negative, right? This could
Right.
be 0, 1, 2, 3 up to so on. So when this is 0, this term will become 0 and will come with 0. It will become 3. When this is 1, this will become 8. When 2, this will become 13. So there's actually a gap of 5 in between. 5,
Yes.
5, right? So this will just keep moving, right? Now let's see what is the first common term in both of these. This is 22. So 22 plus 6 is 28.
Yes. Yes.
So the first common term in both is 28, right? So if you divide 28 with 6, the remainder is 4. 28 with 5, the remainder is 3. But the question actually asks that the n is greater than 30, right? But we just come with the value that n is less than 30, which is 28. So what will be the next value? One way is just keep moving forward. 28 plus 6, again adding 6, and likewise 33 plus 5 plus 5. Isn't that a time-taking approach?
Yes.
The efficient way.
It's a time-taking approach.
Just think this way, that whatever the next value is, that must be a multiple of 6 as well as of 5.
Yes.
So that value must be a
30.
least common multiple of these two. I'm
Yes.
saying that.
30.
So
Yes.
the way
Yes.
to form that is n, which is a number equal to the first common term, which is 28. This is first common term. And this is LCM of both divisors. Here the divisors are 6 and 5. LCM of 6 and 5 into x. Now what is the x is any integer, non-negative, 0, 1, 2, 3 up to so on. If this is 0, we get first value 28. If this is 1, we will get second value. Now what is the LCM of 6 and 5? 30. So our
30.
equation will become 30x plus 28. So when x is 0, our first value of n is 28. When x is 1, our first value will become 58.
58.
When n is 2, this will become 88, right? So there's increment of 30 in each.
Yes.
Got my point? This is a way to quickly
Got you.
just find those. Otherwise, if you start substituting, adding 5 and 6 in each, that will take a lot of your time, right? So the generalized form is the number will be equal to LCM of the both divisors. I'm considering a case in which there are only two values and there are two series. There could be more than that, we will see at end, into some variable x plus the first common term. In our case, the first common term is 28 and LCM of both is 30. So n is equal to 30x plus 28. If you keep doing by this way, you will get next value is 58 common in both, right? Okay, so this is the first way and our value is 58. So the question was, if n is greater than 30, which is 58, and if we divide 58 by 30, what will be our remainder? 28. Got my point?
Yes.
Yes, yes.
Okay, this is one way. There is one more way. Again, okay. We have two equations, 6a plus 4 is equal to n, and the other was 5b plus 3 is equal to n. As we know that the right side of both are equal, both we have n, but if we use even and odd concept here, this is even and this is also even, because even into any integer is also even. So even plus even will result in even integer, right? Using that, if this term is even, so this term should be even as well. How we can come up with the even term on this side? This is odd. So what will be the this so that the addition of these will be even? Can anyone tell that?
Yes, odd.
Odd,
Should
right?
be odd.
So you have to
Yes.
put such values of b so that the output is even, right? For example, if b is 1, so 5 plus 3, this is 8. If b is 2, the result become odd, which is not possible. If b is 3, this is 18. If b is 5, this is 28, 38, 48, up to so on, right? Now just equate these with this. For example, 6a plus 4 is equal to 8. Not possible, because 6a will become 4. And in this case, a is become fraction, which is not possible. So this is not possible. If you take 18, 6a plus 4 is equal to 18. 6a will become 14. Again, not possible, because a is integer. If you take 28, so 6a plus 4 is equal to 28. 6a is equal to 24. And yes, a is equal to 4, which is integer. So our least common value is 28, right? You can do both ways. You can either just substitute values, or you can use even and odd concept. In some question, it is preferable to do this, but in some question, it is preferable to do other way. I will show an example afterward that in that case, if you start doing this, that will be a bit difficult, even time taking. Right? No point.
Your voice is breaking again.
Yes, your voice is breaking down again.
I'm audible, clearly audible now.
You are audible, yes, but sometimes your voice, you are not audible.
Whenever that is the case, just let me know. But for time being, you all got what I'm trying to explain.
Yes.
Sorry. Yes.
Yes.
Can you explain
Okay.
the LCM approach once again?
LCM approach.
Yeah.
Okay, so where was that? Yeah. Okay, the point is you got the first common term.
Yes.
Yeah, shall I say from the start?
No, got it.
Got it. So what will be the next common term? Listen, we have divisor 6 and 5. Whatever the next common term is, that must be a multiple of 6 as well as multiple of 5. So that is possible if that multiple is a least common multiple of 6 and 5. If you take the LCM of that and multiply and add in 28, that will be the next value. 28 is the first common term, and this is just the LCM of divisors into x, and x is the non-negative integer 0, 1, 2, 3, and up to so on. You can find the number of n to any length by using this.
I have a
Got it?
question.
Yes.
Can we make the equation and then plug in the values to satisfy both sides?
Point is, yes, you can do that, but
Because it would be
that is
much
not that easy.
easier.
Okay, listen. You're saying that if you do this way, you are saying that 6a plus 4 is equal to 5b plus 3, right? Okay. How will you
Yes,
proceed?
kind of.
And we have the option, so we can plug in the values.
There are some
No,
cases
no.
in which you don't have the options as. What will you do if you have a quantity comparison question?
No, in this case, we haven't any options like that, because
You can't
in this
proceed by
case,
that way.
yes, at least for this question.
Yes.
Okay,
Okay.
got it.
I will show you example. Okay, there are two more questions relevant to this. Okay, so now just more question just for your practice. The question is that when a positive integer n is divided by 3, the remainder is 2, and when divided by 7, the remainder is 5. The question is how many values of n are less than 100. I repeat the question: when a positive integer n is divided by 3, the remainder is 2. And when it is divided by 7, the remainder is 5. The question is how many values of n are less than 100? Just take 2 minutes and try to solve this question.
Three.
So one answer is 3. Any other answer?
Four.
Okay, 4. Any other answer? Okay, let's solve now. The question says that when a positive integer n is divided by 3, the remainder is 2. When n is divided by 3, the remainder is 2. And when same n is divided by 7, the remainder is 5. Right? Now, just assume a and b are two non-negative quotients. So equation will become 3a plus 2 is equal to n, and 7b plus 5 is equal to n. Right? Now, if you consider a0, this will become 2. a1, this will become 5. a3, a2, this will become 8. a3, this will become 11. and up to so on. Write a gap of 3 between each. And here, if b becomes 0, this will become 5. And see that the first common term is 5 in both. So the first common term is 5. Now instead, just make a formula. What is the LCM of 7 and 3? 21. 21. So n will be equal to 21x plus 5. When x is 0, first term is 5. When x is 1, first term will become 20, second term becomes 26. When x is 2, 47. When x is 3, this will become 68. And when x is 4, this will become 89. So how many values are less than 100? 5 values. 1, 2, 3, 4, and 5. I told you one thing about even not, but in this case, if you start solving from even not, that will be too difficult. Because if this b is even, the answer could be different. It could be, the result could be even, the result could be odd. Likewise, here the result could be even, the result could be odd, right? So in some cases, the using even and odd approach is the very efficient approach. But in likewise, in other cases, if you start using that approach, it will be time-taking approach. So the approach you will be used just depend upon the question, the type of the question, right?
So I want to ask,
Yes.
can you scroll to your left? Why do we take the LCM of both 3 and 7?
Because whatever the value is, that must be a multiple of 3 as well as a multiple of 7.
And then where are we getting this 5 from? Where are we taking the 5 right away?
Because
Common
the
term.
first value is 5. The first value is 5. You need to know the first value to make this formula. This is first value, which is 5, first common term. This is LCM of
Yeah.
divisors into x, and x is a non-negative integer.
Okay.
Actually,
0, 1, 2, 3, right?
Okay, thank
actually,
you.
5 must be the first common term, not the first term.
Yes, first common term. I'm saying first
Okay,
common
thank you.
term, right?
Thank you. Yeah, thank you.
Okay. I even got this question.
Yes.
I have a doubt. I
Yes.
got this n equal to 5 for both. After
Okay.
that, what should we do?
First of all, just know this equation. N will be equal to LCM of divisors, both divisor, into some variable x plus first common term. First common term is 5, right? Just take the LCM of both divisors, 3 and 7. That is 21. So 21x plus 5 is equal to n. Now just substitute the value of x 0, 1, 2, and 3 up to so on. You will just get the value of n right away.
Okay.
Okay.
Right.
Then till less than 100, we
Yeah.
should count, right?
Yes.
Okay.
Otherwise, if you don't want to use the formula, just manually count, but that will be very much time-taking approach, right? Okay. One more question with this, then we will move to the next question time. Okay. What is the time? We have a time. Now the question says that when a positive integer n is divided by,
I have to say something for the previous question.
yes,
If we calculate the value by doing n equal to 21 into multiply some variable, one variable plus 10, I am able to solve this math by doing this equation. Is it correct?
okay, the question was, when a positive integer n is divided by 13, the remainder is 2. And when n is divided by 8, the remainder is 5. The question is how many values of n are less than 180, are less than 180. I repeat the question. When a positive integer n is divided by 13, remainder is 2. And when it's divided by 8, the remainder is 5. So question is, how many values of n are less than 180? We have just 1 minute to solve this question.
Three,
1,
3,
Okay, so
One.
3, 1. Any other
sorry,
value?
not 3, 2. 2, sorry, not 3, 2.
Okay, 2. Any other value? Okay, let me solve now. Okay, the question is that is when a positive integer n is divided by 13, the remainder is 2. When n is divided by 13, the remainder is 2. And when n is divided by 8, the remainder is 5. Again, let's consider a and b as a quotient. So 13a plus 2 is equal to n, and 8b plus 5 is equal to n. In this question, if you start substituting value of a 0, 1, 2, 3 and b at 0, 1, 2, 3, that will take a lot of time. For this question, I would suggest just use even and odd concept, because this will be even and this will be odd. So their result is always odd. So for getting an odd value, a will be 1, 3, 5, 7 up to so on, right? So when a is 1, this is 15, then a is 3, this is 41, 68, 93. So just compare these with the, equate these with these. So 8b plus 5 is equal to 15. In this case, b is not integer. Next, 8b plus 5 is equal to 41. In this case, also this is not integer. 8b plus 5 is equal to 68. In this case, also not integer. But in case of 8b plus 5 is equal to 93. In this case, 8b is equal to 88 and b is an integer. So first common term is 93. So first common n will be equal to 93 plus, what are the two divisors? Those are 8 and 13, right? So just multiple of 8, 13 into x. So when x is 0, first term is 93. But when in x is 1, the second term is way greater than 180. So there's only one term which is less than 180. Everyone is with me?
Okay,
I
okay.
just lost the track after even and odd thingy.
Okay.
Can you repeat it, please?
Okay, see. This thing is, this is odd, 5 is odd. And here
I
8b.
got it. I got it. After this, what did you do?
Okay, this is odd, right? This is n, this is n. So this one also be odd. When we can get this n as odd? Because this is even and this has to be odd so that the result is odd. So when this would
Yes.
be odd, when a is 1, a is 3, a is 5, when n a is odd. When you put a as 1, the result is 15, a is 3, result is 41, a is 5, result is 68, 493, right? When you start substituting values, you will get these. Now just simply equate these to this equation, 8b plus 5 is equal to n. So in whatever case you will get b as an integer, that will be your first common term. and that is 93. Got the point?
Sorry, can't we? Now it depends on using on the both side, right? Either we use the that of one side or the other side.
You're not audible.
Hello.
Yes, yes. Repeat your point.
Okay, I said it doesn't. You can use any of those two sides. Either I start from the 32 plus
Yeah, you
8
can
to-
start from any side, either this side or this side. But in last,
Alright,
you have
alright.
to equate both of these.
Okay, thank you.
And just the point is that these are integers. Just keep this in mind. These are non-negative integers, 0, 1, 2, 3. Perfect. Okay. Now let's see another way how the question could be asked. For example, if the question is like, if A
Excuse me, sir. So what is the answer?
1, because first common term is 93 and the LCM of both is very bigger. If you substitute 1 in this, the result is around 197 and that is greater than 180. That's why only one, which is 93 is answer. One is answer.
Oh.
All right.
Yeah, thank you, sir.
Okay. The next question was, if A and B are positive integers such that A over B is equal to 97.16. The question says, which of the following could never be a which of the following cannot be the remainder when A is divided by B. I will repeat the question that if A and B are positive integers such that A over B is equal to 97.16, question is, which of the following could never be a remainder when A is divided by B? The options are 4, 12, 22, 28, and E is 96. So you have just 1.5 minutes to solve this question.
Can you repeat the question again?
If A and B are positive integers such that A over B, A divided by B is equal to 97.16, which of the following could never be a remainder when A is divided by B? Okay, so one answer is C. Any other answer? Okay.
96.
E96. Okay, two answers. Okay, let me solve this now. The answer is C, 22. We are given that A and B are positive integers such that A over B is equal to 97.16. Okay, first of all, when A is divided by B, right? And let's suppose our quotient is Q and remainder is R. We can write this as BQ plus R is equal to A. And if we divide both sides with B, this with B, this with B, this will become A over B is equal to Q plus R over B, right? I'm just dividing B on both sides. Now, first of all, as I told earlier that this is divisor and divisor must be greater than remainder, right? So this term has to be a value less than 1 or the fraction value, right? So the question is, we are given that A over B is equal to 97.16. We can also write this as A over B is equal to 97 plus 0.16. If we equate this, Q will be 97 and R over B will be 0.16, right? Everyone is with me till now? Okay, so now Q is equal to 97 and R over B is equal to 0.16. We are just need of this thing, R, right? So R over B can also be written as 16 by 100. If we further simplify, this will come out to be 4 over 25, right? So from this, we can straight assume that the R must be a multiple of 4. That's why if you see the options, A is a multiple of 4, B is a multiple of 4, D is a multiple of 4, E is a multiple, only C is not a multiple of 4, which is our answer. Right?
Can you repeat the last portion? Can you repeat the last portion?
Last portion, that R over B is equal to 0.16. Just
Yes.
remove the point. There are two values after 100. So just simplify this. If you divide 2, so this will be 8 over 50. So again, by dividing by 2, this will be 4 over 25, right? So in this
Yes.
least form, the remainder must be a multiple of 4, right? That's why
Yes.
if you just see the options, this is a multiple of 4, this is a multiple of 4, this is a multiple of 4, this is also a multiple of 4. Only 22 is not a multiple of 4. That is what the question asks, which of the following can never be a remainder when A is divided by B. Got my point?
Yes. Yes. I got you. Thank you.
Okay. That's a very interesting question. The question states that today I'm just trying to give the perspective how the question could be asked from different ways, right? Okay, for example, let's suppose M is a positive integer, and the question given is that M over 15 is equal to 8.2. So question is, what is the remainder when M is divided by 30? I will repeat the question. M is a positive integer such that M over 15 is equal to 8.2. So the question is, what is the remainder when M is divided by 30? You have just 1 minute to solve this.
Three.
Okay, so one option is 3. Any other option?
Is 3 multiple of 3?
3.
Yes, 3 is the answer. This is a very simple question. M over 15 is equal to 8.2. You can also write this as M is equal to 15 into 8.2. This can also be written as M is equal to 15 into 8 plus 0.2. This will be equal to 15 into 8 plus 15 into 0.2. So 8 can be written as 2 into 4 plus this is 3. So M is equal to 30 into 4 plus 3. Now if you divide this by 30, this is multiple of 30, so remainder is 0. We are left with 3 by 30, and this is less than 30, that's why the remainder is 3. Now, if I just change the question, and instead of 8.2, let's suppose if I make this m of 15 is equal to 9.2. Now, what will be the remainder if we divide m by 30? What will be the remainder?
18.
18, yes. Again, this is very basic. M will be equal to 15 into 9.2. M will be equal to 15 into 9 plus 0.2. So M is equal to 15 into 9 plus 3. Now we can write 9 as 15 into 8 plus 1 plus 3. So 15 into 8 plus 15 plus 3. So this is 30 into 4 plus 18. And if we divide this by 30, this remainder will be 0 and we are left with 18 by 30. Again, the dividend is less than divisor. That's why 18 will be the remainder. I hope there is no confusion till now. That's why I'm moving quickly. Everyone got this?
Yes, yes, got you.
Okay. Similar, there's a similar type of question that let's suppose if we are given that x is a positive integer. And the question is 1 over 2 plus 1 over 3 plus 1 over 4 plus, not 1 over 4, let's make this 1 over 5, 1 over 7 plus 1 over 11 is equal to x over 2 into 3 into 5 into 7 into 11. The question is if x is a positive integer such that this expression is possible. The question is, this is a quantity comparison question, quantity A and quantity B. Quantity A is remainder when x is divided by 7 and this is 5. I will repeat the question, x is a positive integer such that this expression holds, that 1 over 2 plus 1 over 3 up to 1 over 11 is equal to x over 2 into 3 into 5 into 7 into 11. The quantity A is remainder when x is divided by 7 and quantity B is 5. You have just 1 minute to solve this question.
Option B.
Okay, so one answer is option B. Any other
Option
answer?
B.
B?
Option B.
B. These, no, these ones.
Okay, so all of you are with B. Anyone who is still solving, or shall I solve this now?
Solving.
Okay, so there is one D as well. Just be quick. Try to solve this as quick as possible.
B.
B? Okay, so
B.
B or D?
I said B.
Okay, so the answer is to this is B. Okay, if you just see the expression 1 over 2, just first simplify this expression. If you just take the multiply this, cross multiply to this side, right? So what will be the expression? At first, 2 will cancel out. We will, okay. I was telling that just cross multiply this denominator, right? So this is 2. So at first we will have 3 into no space here. Okay, we will have 3 into 5 into 7 into 11 first, plus second one will not include 3, all values other than 3. 3 is not included. Third one, all values other than 5. Fourth one, all values other than 7. And next one, all values other than 11 is equal to x. You're getting what I'm doing? Just multiplying this to the left side, and like at the first, divided by 2. So there is no 2 in this, except all values are there. I'm just doing shortly right now. Okay? But if you divide this by what the question asks, divide this by 7, right? Okay, so in this there is 7, so remainder is 0. In this there is 7, the remainder is 0. Likewise from this 0, from this 0, but there is no 7 in this term, which is 2 into 3 into 5 into 11. 7 is equal to x by 7, and rest all of the others have remainder 0, right? Now just quickly solve this. We have 2 into 3 into 5 into 11. So 2 into 3 is 6. 6 into 5 into 11 over 7. Okay, so we can also write this as 6 into 5 into 7 plus 4 over 7, right? So this will become 6 into 5 into 4 divided by 7. Anyone with me? In any case, I am doing mistake, please let me know. I'm audible or still the network issue?
No, you are audible.
Okay. Okay. Just hold for a second. Where were we? Okay. I'm doing right till now, right?
Yes.
So this is 6 into 5, 30 into 4 divided by 7, right? So what is the multiple of 7 less than 28? Less than 30? 28 plus 2 over 7 into 4, right? So this will be 2 into 4 over 7, right? This is 8 over 7, and the remainder is 1. Anyone is with me?
Yes, the remainder is 1 for the
Yes.
first part.
And the
But what,
yes.
what about the 4 by something? 7. Okay. I didn't get you.
Can you please
I didn't
repeat
got.
it again? I just
From where?
lost you at
From where you
from
got?
where you equate the equation by
Okay, let
x
me
by
solve this
7.
completely. Okay, let me solve this question again.
No, I got you from the start, but the part where you equate the equation by x over 7.
Okay, so you are with me till this point.
Yes,
No,
yes.
please. It will be very helpful if you continue from the first.
Okay, let me completely solve this question again now. We have 1 over 2 plus 1. Please mute yourself. 1 over 5 plus 1 over 7 plus 1 by 11, right? We have 1 over 11 in the question, right? Okay. 1 over 7, 1 and 11 is equal to x by 2 into 3 into 5 into 7 into 11, right? This was the question.
Yes, this
Just
was.
multiply this to the that side, right? So first of all, we will have 2 into 3 into 5 into 7 into 11 into 1 by 2, 1 by 3, 1 by 5, 1 by 7, and 1 by 11 is equal to x. If you multiply this to each term separately, So first will become 3 into 5 into 7 into 11. First, there is no 2 in this, right? Because 2 is cancelled out. Second one will have no 3 in this. Oops. This will be 5 into 7 into 11 divided by no 3 in this. Third one will have no 5, 2 into 3 into 7 into 11. The fourth one will have no 7 in this, 2 into 3 into 5 into 11. And the last one will have no 11 in that, 2 into 3 into 5 into 7, right? There is no 11 and result equal to x, right?
Right.
Divided by 11.
Now, if you divide this whole thing by 11, so at first there is 11, right? So this term is multiple of 11. If we divide this by 11, the remainder is 0. Now see here, again there is
No,
11.
we will divide this by 7. Question has 7.
Yes, the question is 7. How? Why you are dividing?
Okay.
So,
I divide this by
still the
7,
remainder will be 0.
yes, because there
it
is a
has
multiple of
7.
7. If we divide this by 7, this is again a multiple of 7, that's why remainder is 0. If I divide this by 7, again, the remainder is 0. For this case, again, remainder is 0. We are just left with this case, right? 2 into 3 into 5 into 11 divided by 7 is equal to x by 7 because we are dividing 7 on both sides.
Okay. Yes, yes.
Now x by 7 is equal to 2 into 3 into 5. You can solve whatever the way you like, but I will just solve with the property I used earlier. Because there's 11, we can write 11 as 7 plus 4, right? So this will become 2, 3, 5 into 7 plus 4 divided by 7, right? Now we can also write
Right.
it as, because 2, 3 into 5 into 4 divided by 7, because 7 will get the 7 over 7 will have no remainder. So we are left with 2, 3, 5 into 4, right?
Yes, 2, 3, 5 into.
Now we can write 3 into 2 as 6, 6 into 5 into 4 over 7. Now 6 into 5 is 30, 30 into 4 by 7. Now what is a multiple of 7 less than 30? 28. We can write this
28.
as 21 plus 2 into 4 over 7, right? So again, 28 is divisible by 7. The remainder in that case is 0. So we are left with 2 into 4 over 7. This is 8 by 7, which is 7 plus 1 over 7, right? So that is equal to 7 by 7 plus 1 by 7. Here the remainder is 0 and we are left with 1 over 7 because this is less than the divisor. So the remainder is 1, right? There's another way using the negative remainder concept, which we will discuss tomorrow. Negative remainder. That is a very interesting concept. Negative remainder, successive remainder, successive division, and many more. We will solve these. This is very helpful in the remainder questions, extremely helpful in such question which we are dealing right now. But if at first I were to explain it, that will take time, and we will do this by tomorrow. Okay, so till now there is no confusion.
No, but can you give another question of this sort? We have 5 minutes left. So we can do another question if you have.
I have other questions, but those are a bit lengthy. Okay, that's not of this sort, but another question. Last question for today. The question is that when x is divided by n, the remainder is 3. Which are the following could be the remainder when x is divided by 20. I repeat the question. When x is divided by 10, the remainder is 3. Which of the following could be the remainder when x is divided by 20? Options are 0, 3, 5, 8, 10, 13, and 20. We have just 1 minute to solve this question. When x is divided by 10, the remainder is 3. Which of the following could be the remainder when x is divided by 20? Just quickly solve this. Only 1
3
minute
or
for
30.
this. Yes?
3 or 30.
3 and
13.
13. Okay, just quickly solve this question. Only half minute left.
Thirteen.
3 and 13.
13. 3 and 13.
13 and 3 and 13. Yes, 3 and 13. This is very easy question. And if no one is confused, so I won't solve this. If any one of you want me to solve this question, please let me know. No one? Okay, I have some other questions, but those are a bit difficult question and a time-taking question. So we will solve those tomorrow. And still, it will take a long session to complete this reminder. There is much more to be covered in reminder, right?
Can
So
you please solve this one?
Okay. The question is that when x is divided by 10, the remainder is 3, right? So let the question is A. So 10a plus 3 is equal to x. The question says, what is the remainder when x is divided by 20, right? So x by 20 is equal to 10a by 20 plus 3 by 20. So first of all, 3 will always be on this side. Okay, if a is 1, first of all, a is 0. In that case, this is 0. So there is no remainder from this side. But if a is 1, this will become 10 by 20. In that case, this came out to be 10 plus 3. The answer is 13. But if this is a multiple of 20, let's suppose this is 20, 40, 60. In that case, this will become 0 and the remainder will be only 3. So possible answers are 3 and 13. Just substitute non-negative integer in place of a 0, 1, 2, 3. For even integer, you will get 3 remainder. And for odd integer, you will get 13 remainder.
Yes.
Perfect.
It's fine.
Okay. So anyone of you learned new things today, or this is just overview?
Oh, yes. Yes, I have learned so many things. It's really appreciable.
Okay. So no confusion for now.
No, thank you so much.
No, thank you.
No, thank you.
Perfect.